Hi, my name is Darren Marchesani, and today I'll be conducting an experiment to see if boiling water freezes faster than cold water. It's well known that the water's freezing point is 32 degrees Fahrenheit or 0 degrees Celsius, so to keep the experiment interesting, I'll be adding salt and sugar into my cups of water. I'm doing this experiment because I was really interested to see if boiling water freezes faster than cold water or if the temperature of the water doesn't matter at all. I hypothesized that the boiling sugar water will freeze faster than all the other cups of water, including cold sugar water, as well as the boiling and cold cups of salt water. I believe this will happen because sugar has less molecules compared to salt, which I believe plays a factor in how fast it takes for the two to freeze. I also believe the boiling sugar water will freeze due to the Mpemba effect, which is a theory that scientists developed to try to explain why hot water freezes faster than cold water. Some of the explanations include the fact that hot water evaporates faster, reducing the amount left to freeze, as well as the formation of a frost layer when water is cold that causes insulation. This unfortunately hasn't been able to be proven to be true, and it's still only a theory because there are plenty of cases in which cold water is frozen faster than boiling water. While I'm conducting an experiment, it's important to know that when adding sugar or salt to water, the freezing point of water becomes lower, due to the fact that the sugar and salt, when mixed with water, forms a homogeneous mixture, meaning that the mixture is equal parts water and salt or sugar. It changes the freezing point. Hydrogen bonds in water are required for the water to become solid or freeze, and the sugar and salt prevent the water from making these hydrogen bonds, forcing the water to have to become even colder than usual for it to reach the freezing point. This means that water's freezing point undergoes what's known as freezing depression, meaning the freezing point of the solution is less than the freezing point of the pure solvent, so the freezing point of sugar water and salt water is less than the freezing point of regular water. The materials I'll be using today are plastic cups, water, a hot pot to boil the water, a plastic spoon to mix the sugar and salt in the water, sugar, salt, and a freezer. When conducting the experiment, I will use the 4 cups of water as my samples. Before pouring the water into the cups, I will make sure to boil some of the water in the hot pot to pour into 2 of the cups. 2 of the cups will contain boiling water and the other 2 will contain cold water. In each set, there will be a cup containing sugar water and a cup containing salt water. After I mix 4 spoonfuls of salt and sugar into the cups, I will place the 4 cups into the freezer and check on them in 1-hour intervals, reporting any changes made to the water. At the end of the experiment, I hope to find that my hypothesis was correct and that the boiling sugar water will freeze faster than the other 3 cups of water. Now the water is boiled, so I'm going to pour the boiling water into the cups. The boiling water has been boiled, so now I'm putting in the cold water into the cups. So I've mixed everything into my 4 samples, and before I place it in the freezer, I just wanted to show you guys something cool. If you notice the size of the cups in the boiling sample, now just keep the note of the size. You notice the size of the cups in the cold sample. Big difference. And clearly it's a big difference, but I completely forgot that boiling water and plastic don't mix, and something like that would more than likely happen. So it was a brain fart and a mistake, but it doesn't damage the experiment at all. It was just really cool watching plastic shrink to size right in front of my eyes. It was amazing. So I'm going to place everything in the freezer now, and I'm going to check back in an hour, and it's about 10:15, so 11:15 I'm going to check again, and then so on and so forth until I see results. This shows me placing the 4 samples at around 10:15. The picture was taken at 10:17, but the experiment really began at 10:15. In these next 2 images, you see me analyzing the 4 samples at around 11:15, which is exactly an hour of placement in the freezer. And in the next image, you'll see that I observed that there was ice starting to form at the bottom of the cold sugar water sample. In this image right here, I recorded a couple changes that occurred at 12:15, which is 2 hours after placing it in the freezer. And you see that in the boiling sugar water, ice is beginning to form, and in the cold sugar water, it's frozen even more, and the ice has reached more towards the surface.
At around 1:16, I pulled all the four samples out of the freezer, and there's no observed changes over since the last hour. The salt water, there's still no ice forming at all in either of the samples, and no further ice is formed in the sugar water samples. At 2:15, I pull out the four samples, and I noticed that in two of the samples, both sugar water samples, that it almost looks like a slushy or like the ices that you get at the store, and that there's some ice there, but it's still very liquidy and kind of gross. At 3:15, I pull out all four samples again, and I notice that the cold sugar water sample becomes even more frozen, and it doesn't really look like slush anymore. It looks more like a solid block of ice, yet there's still slush present, and there was no observed change in the other three samples. At 4:15, the experiment concluded as the cold sugar water had frozen completely solid. Um, and observing the other three, the the boiling sugar water, while it was frozen, it still had a little bit of the sludge present, but not as much as it had at the previous hour. And the salt water sample still had no ice at all. And I'm going to touch more on that later on in the video.
After placing the four samples in the freezer at 10:15 in the morning, the experiment concluded at 4:15 in the afternoon as the cold sugar water was frozen solid. The boiling sugar water was also frozen, however it resembled more of a slushy than a block of ice, like the cold sugar water. The saltwater samples didn't freeze at all, allowing me to conclude that it would take much longer for saltwater to freeze. I also know that salt is often used to melt ice, so that could be a big reason as to why it took so long for saltwater to freeze. And here are the samples. This is the cold sugar sample. As you can see, it's frozen solid. And here's the boiling sugar water sample. And as you can tell by me scooping in here, what I mean by slushy. The ice is more slush rather than ice. And here are the salt samples. As you can see, it's still water, no ice is formed at all. Maybe a little bit at the bottom, but not too much. It's no ice really at all. Didn't freeze whatsoever. So my hypothesis was incorrect, and the boiling sugar water didn't freeze the fastest. In fact, the cold sugar water froze the fastest. I thought that maybe the Impemba effect would take into account. That's why I believed that the boiling sugar water would freeze faster, because I believed that hot water would freeze faster than cold water, which is what the Impemba effect really states and tries to prove, even though it's only a theory and it's been proven many times that sometimes it's not the case. So after a few days of processing the results of the experiment, there's a few things I didn't expect. I didn't expect for the results of the experiment to take nearly as long as it did, as it took 6 hours for one of the four samples to freeze completely solid. And even after almost 29 hours, neither saltwater samples froze completely. As you can see here, nothing. There's a little bit of ice, but I can't tell if it's ice or a separation of salt from the water. But I didn't do that to continue on with the experiment. I just wanted to see if it would how long it would freeze or which one would have frozen first. But there's a couple things I would have changed with the experiment. I think in order to have changed my results or at least gotten better results, meaning that my results would have been quicker and more efficient, um, I would have measured exactly how much water to place in the cup using a measuring cup. I eyeballed everything, which is probably, it's not baking, it's science. So I probably should have had exact measurements, or rather, not probably, but I definitely should have had exact measurements, which I didn't, and that was a mistake on my part. But um, we live and we learn. Um, and to build off of that, I did the same thing with the water. And I did the same thing with the salt and the sugar. Rather than measuring things in tablespoon, teaspoon, so on and so forth, I just poured the salt in the spoon until the spoon was completely full. Like there couldn't be any more, so I dumped everything in there. And the same thing with the sugar. And obviously, using tablespoon, all other stuff, would have been more efficient, and maybe I could have gotten better results. Um, Another thing I would have changed, or maybe not would have, but at least could have changed, is the material in which the cups I used. Um, Doing my research after the experiment, I found out that there are other materials that aren't as good as with insulating than plastic. paper is a lot thinner than plastic, and that means there's less of an insulation. So because of that, I probably could have gotten results quicker because paper is less thin, therefore there's less insulation of the plastic. Rather, the water would have frozen much faster, and it would have taken maybe less than 6 hours for at least one of them to freeze, and maybe all four would have frozen at one point instead of this, where 2 out of the 4 samples didn't freeze even after almost 30 hours now. But also what I could have changed was changing the temperature of the water. Um, I got room temperature water and I put that in the hot pot and boiled it until there was steam, knowing I should stop and poured that water in there. But instead of doing that, I could have used just hot water from the faucet, like I used cold water from the faucet, and maybe that would have changed the results, and maybe my hypothesis were right, and the hot water with sugar would have frozen faster than everything else. Um, but again, I didn't do that. So, but that one doesn't bother me as much as the other ones. Another thing I could have changed, which is less realistic, is use a different fridge. Since I live in a dorm room, I can't get a bigger fridge. Um, my fridge, while already small as it is that's the max. That's the biggest size fridge I'm allowed in the dorm room. I'm not allowed to get any other big fridges, and because of that, my freezer is small. And I think with the bigger freezer, um, things things freeze faster in a bigger freezer, and my freezer has a hard time not keeping things cold, but it has a hard time getting things cold. It's good at maintaining um, temperature, but it takes a little while for things to freeze in there. So I definitely could use a different freezer, but again, it's not realistic. I can't afford a new fridge, and one I couldn't afford a new fridge, and two, I'm not allowed to have a bigger fridge anyways. Um, but regardless of all of the things I did wrong and that I could have improved upon. I had a lot of fun doing this experiment, and I'm glad this was my midterm. I'm sure I know there's another assignment, but this was a lot of fun, and it was I kind of felt like a kid again, being able to perform scientific things, even though this isn't really all that scientific um, on the surface. But going deeper into it, I found out there was a lot more to it than just water freezing based on hot or cold. I found out about the Impemba effect and all those other great things. Um, so I want to thank you, and I hope you guys enjoyed the awkwardness all throughout the video. Um, I was really awkward, and I'm probably being awkward right now. But anyways, thank you guys. I had a great time. Thank you, Professor, and hope you guys have a great rest of your night and enjoy the entire video.